Okay, so looking at adding and subtracting polynomials, again, really this is all about just combining like terms. So before we get going, I want to just refresh your memory as to what like terms are. So if we're looking at like terms, does anybody know the meaning of like terms? It's kind of self-explanatory. Terms is just another way of saying an item. So these are items that are alike, that are the same or similar. So if we had, for instance, I don't know, we'll say 5. If I had the number 5, what would be a like term? Okay, it doesn't have to be exactly the same number, but it could be any other number. So if this is just a plain number, a like term would be any other plain number. We could even have negatives, so like negative 13. That would be a like term. You could have 1002. Doesn't matter. They're all just plain numbers, so they're all alike. What if we had, let's say, x squared? What would be a like term for x squared? For this one, so your like terms, again, they have to be very similar. Your like terms have to have the same variable and the same exponent. It doesn't matter what number, what coefficient they have in front. As long as anything else has an x squared, it would be considered a like term. So we could have negative 2x squared. We could have 10x squared. As long as they have that x squared piece on it, they're considered like terms. You can combine them. Okay, same variable, same exponent. So then what if we had negative 3x to the 5th power? What would be a like term for negative 3x to the 5th power? Anybody make up one? No, no brave soul. All right. Again, all you have to have is x to the 5th power. So we could have a plain x to the 5th power. That would be a like term. Same variable, same exponent. We could have a positive 8x to the 5th power. Again, it's the variable and the exponent that you look for. So you have to have same variable and exponent. Okay, so this comes into play when we're going to be doing our worksheet and looking at adding and subtracting these polynomials. Polynomials on your worksheet is just a fancy way of saying multiple numbers, multiple items in your problem. Poly means multiple. So for problem number 1, if we want to combine 5p squared minus 3 plus 2p squared minus 3p to the 3rd. First thing that I notice here is that I have this plus sign in the middle. If I have this plus sign in the middle, I'll zoom in on that, sorry. Is that going to affect anything in that second parentheses? Does it change anything? No, it doesn't change anything. Okay? Essentially, I don't even need to have this parentheses on there. Because I have a plus sign in there, I can drop the parentheses immediately. So that plus sign means I get to drop the parentheses, and then I'm just combining like terms. So what we're going to do as we work through these problems, each item I come across in my problem I'm going to circle, and then I'm going to go through it and see if there's a like term that matches up. So the first item I have here is a 5p squared. So I'm going to look through, do I have any other p squareds? Yes. Yes, I do. I have 2p squared in that second parentheses. So I'm going to circle my like term. I'm also going to circle the symbol that sits in front of it. So in this case, it's a plus. And that's all I'm doing. I'm combining them, I'm adding them. So this is a little blurry. Hold on. Let me fix that. Sorry, guys. Is that better for y'all? Yes? No? Didn't make any difference? Okay. So 5 plus 2 is going to give me 7, and the p squared tags along. Once I have it written down, once I've combined it, I'm going to scratch through it. That way I make sure I'm not using something more than once. The next piece that I have in there is that minus 3. Minus 3 is a plain number. Do I have any other plain numbers in my problem? Nope, that's the only plain number that I have, so it combines with nothing. I'm just going to bring it down. Minus 3. Again, once I list it, I cross it off. Then I go on. The last thing that's in my problem here is this minus p to the 3rd power. Or sorry, minus 3p to the 3rd power. Obviously, I've scratched through everything, so is there anything for it to combine with? No. So I could go down and I could tack this onto the end, minus 3p to the 3rd power. However, I will say It's not critical for you guys to do this. I would accept it anyway. But the technically correct way to write this would be put the biggest exponent in the front. So this has the biggest exponent of 3. It's going to go in front of everything else. So I would have negative 3p to the third power in front. And then I have to have some connecting piece. So if that 7, or that 7p squared, was that 7 positive or negative? Positive. So what little symbol do you think I should use to connect these? Adding a plus sign, that positive symbol. Okay? And that would be my simplified answer. All right, so let's look at problem number 2. Problem number 2 on your paper is the same idea, but now we are subtracting. So again, looking at the problem, the first thing I notice here is that there's a subtraction sign. When you see that subtraction sign in front of your second parentheses, that means that you are going to change the signs. All of the signs in that second set of parentheses are going to change. So if I'm looking at just the parentheses here, the 3a squared, is that a positive 3 or a negative 3 inside the parentheses? It's a positive 3. So if this was a positive 3, I'm going to rewrite it now, and it's going to be a negative 3a squared. My 4a to the third power had a minus in front, so now it's going to have a plus 4a to the third power. I'm just going to write it above, and then I'm going to scribble through the original, including that subtraction sign. That subtraction sign made me change all the signs, so now it's gone, it's blended in. Really what happens here is you're distributing in a negative 1. Okay, now that I have it rewritten, I changed my signs because of the subtraction. I am now going to combine like terms. So I see the first thing I have is a to the third power. Do I have any other a to the third powers? Yes, 4a to the third. So I'm going to circle it. I'm going to circle the sign in front, which is a plus, and then I'm going to combine them. So if I have an a third here and I'm adding 4 more, how many do I have total? 5. I have 1 here, and I'm adding 4 more to it. So that gives me a total of 5, a to the third power. Again, those pesky little 1s are everywhere. There's a little 1 sitting in front of that first a to the third power. Just so skinny it doesn't show up. Poor little thing. So it always gets forgotten. All right, so once I combine them, I'm going to cross them off. Taking care of that. Then I'm going to move on. The next piece that I have is minus or negative 2a squared. Do I have another a squared? Yes, that minus 3a squared or negative 3a squared. So I'm going to circle those two and I'm going to combine them. They're both negatives. I'm just getting more negatives. More negatives altogether. So what do I end up with? Negative 5a squared. I can scratch through them, and then I see I've taken care of everything in my list, and I am done. Last thing I check for, is my biggest exponent first? Yes, 3 and then the 2, so I'm good. Questions, comments, concerns? No? Okay, I'm going to do one more problem, problem 11.